Hello guys, welcome back to Techdose, and in this video we will understand the term consistency in system design. Prior knowledge of scalability is required in order to continue. If you don't know about scalability, you can watch it. I have already made a video. The link for it will be in the description below. In order to understand consistency, let us take an example of a food delivery system. In this system, let's say I am present here and I'll be making a request for placing an order for food. And let's say there is an outlet S1 which is on the second floor of a building, and it can serve a maximum of 100 requests per hour. So the request response has been shown as a sequence diagram. The number 1 is showing that this is my first request to S1, so I'm placing the order to outlet S1. Now S1 will be acknowledging that the order has been confirmed, the order has been taken. So this is number 2, which is order confirmation. Then after some time, maybe I will like to ask about the status of my order. So this is shown in number 3, where I'm asking check the order status. S1 will now be replying to me about the order status, and this is nothing but reply order status. In this case, since it is the same outlet and I am asking the same outlet wherever I had made the order, it will always come to me correctly. After placing the order, the status will always be correct. Now let's say that the load actually increased, like S1 was doing really well and a lot of customers started coming into the outlet S1. So let's say the number of requests which S1 is now receiving is 150 requests per hour. So since it is getting more requests than what it can serve, in order to make more profit, what this S1 did was it also acquired floor 1, which is the first floor. So it was already acquiring second floor of the building, and now it also acquired the first floor. Now we are using the same food delivery system application, maybe the same phone number as well, and so we will be following the same process of actually making the request and getting the response, right? So if you already know about scalability, in order to serve more requests than your capacity, we actually scale up the systems, right? So if you have already scaled up and now you are acquiring 2 floors in the same building, it will be called as the same outlet probably. Now if you make the order, like let's say we place the order, this is shown by 1. So we are placing the order and it went to S1, which is on the second floor, right? And then S1 will confirm our order in this sequence diagram number 2, right? And then after some time, maybe we will like to know about the order status. So this is a router in between. The router will actually route your request to one of S1 or S2, either second floor or first floor, or we may also have a setting of sending the request to both the outlets, right? So in this case, let's assume that it is routing the request to either of S1 and S2 because it is the same outlet present on a different floor of the same building. So let's say when we make the request of checking the order status, which is number 3, then the checking the order status is going to S2. Now since we had placed the order in S1 and now we are asking S2 about what is my order status, maybe S2 will reply by saying that there is no such order placed, right? So S2 may not be knowing about the order which you had placed and which went to actually S1. So what happens in this case is, after placing the order, when you are asking about what is my order status, it is saying there is no such order placed by you. And hence this is getting caused because the data was not shared between S1 and S2, because S2 has to know about the orders placed on S1 so that S2 can correctly reply you. But since there was no data sharing between S1 and S2, it actually created some kind of inconsistency, right? So whenever you fall into such kind of situation, you will say that this is inconsistent. So here you see that the data is being inconsistent because of no data sharing between S1 and S2. So in order to get over this, in order to make everything consistent, that you don't care about where you place the order, but whenever you ask for the status after placing the order, you should always get the correct result. In that scenario, what we will do is we will link this S1 and S2 for data sharing. So as soon as you make a order to either S1 or S2, the data will be shared between them. And when the data is shared, then it doesn't matter where you had placed the order and where you are asking, you will always get the correct result, and so it will now be consistent. So data will now be consistent. So if S1 and S2 were sharing data, and if you had placed order on S1 and asking S2 for what is my order status, then S2 will correctly reply with the order status. So this is the difference between inconsistent data and consistent data, right? Now let us understand in our systems how it works. So let's take an example of a banking system. In a banking system, if you are present here and you are making a transaction, let's say the initial balance was $500 and you would want to transfer $100 to somebody. So the first request is you are requesting your bank outlet or S1 to actually transfer $100, and then you will get a reply from S1 saying that the transfer was successful. And if you want to check the balance, then S1 will reply with the balance, and the balance will probably be $400, right? Because you had transferred $100. In this case, just after the transfer, at any point of time, if you check for the balance, it is always correct. And so this is said to be consistent, right? There is no problem. There is no problem because you are asking the same server or the same outlet for the change. Now let's say that S1 was actually able to handle 100 requests per second, and now there are more requests because the number of subscribers to the bank outlet actually increased, and so it was required for it to scale up. So when it's scaled up, maybe it acquired different floors or it used another server with another set of databases and all. So after scaling up, let's say S1 is now the second floor or the second set of systems, and this is the first set of system on first floor, right? So now 2 floors have been acquired. Now if you are making a transfer request and it is going to S1 through the router, then S1 will reply that okay, the transfer is successful. Now if you are asking what is my current balance, this is shown by number 3, and this question is going to S2, which is maybe on the first floor or maybe a different set of databases and systems, then S2 will say that you still have $500. You already had $500, you made a transaction and the transaction was done through S1, and S1 will reply that the transaction is successful, and so the balance was changed from 500 to 400. But since this information was not shared with S2, so the balance which S2 knows about you is still $500, right? Which is not correct, which is incorrect, and so it will be said to be inconsistent because certain set of operations actually happened. You did a transaction, but the change was not reflected in S2. So it is incorrect, and whenever you get incorrect data, then it is said to be inconsistent as well. Now in order to make everything consistent, maybe you will have to turn on data sharing between S1 and S2 in such a way that if something was done in S1, it will be shared to S2 and vice versa, right? So if you turn on this data sharing, then depending on how quickly or how frequently you share the data will be consistent, and there are multiple types of consistency, multiple patterns are there, which is actually based on how frequently you share the data between these systems. We can conclude that consistency is closely related to correctness. If every time you get correct information, then the system is said to be consistent. If you don't get correct information, then this is said to be inconsistent. There are different levels of consistency: strong, weak, and eventual. We will look at these in our next video. I hope you were able to understand about the consistent versus inconsistent systems. I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort, and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. I hope this video was helpful. Please like and share our video and subscribe to our channel for more such videos. See you guys in the next video. Thank you.